Hello, everyone, and welcome to this webinar on lifetime extension opportunities and through life management strategies. My name is Lindsay Coulson, and I am the project director at New Energy Update by Reuters Events. We are running the 12th annual Wind Operations Europe 2020 conference next year in Munich on 5th and 6th of March. Essentially, this webinar was created in conjunction with that event, so sort of many of the speakers that are on board today will be speaking again at the event. So do sort of listen in. If you have any questions throughout, do feel free to send them in. We'll have 20 minutes at the end to field off those questions, and then hopefully sort of our speakers will be happy to answer any additional questions, as often we get quite a lot through. So without further ado, I'll hand over to Karl to do the introductions, and I hope everyone enjoys this webinar.
Good morning to the audience, and thank you, Lindsay, for giving us the opportunity to talk a little bit about lifetime extension. I think this is a buzzword in the industry that is used very much, and I think there is a lot of things to be discussed about because it is not completely clear. Also, there have been different approaches in different countries how to deal with it. And I would say this is exactly what we would like to discuss, and it's an honor to host or to moderate this this panel today. We have here a dedicated group of specialists which are also part of the draft committee for the IC 61400-28. Which is a draft technical specification for lifetime extension, or as we call it, even better, through life management. Out of this group, it is really just a short group because, or a short, small selection of people out of this group, because we have more than 40 active members in the draft group. It's a very active group. And we are all proud that we have been able to come up with almost the first draft in a little bit more than a year now, and we hope that we can deliver the first draft by end of this year. What we would like to discuss today is more or less what we are discussing since 1 year in this group. And on top of it, a little bit talking about the motivation for lifetime extension and through life management, as well as the business cases. So in that aspect, we will also cover things like the multiple approach, stage approach that we have been taken, documentation that is necessary in order to come up with good business cases for lifetime extension, the information that it needed, which risks are involved in this, standardization and certification will come at the end. So how can we make sure that everybody is approaching this in the same way? In that aspect, I would like to jump directly into the discussion. And let me first of all introduce the panelists here. We have Rémi Stein from Engie, who is a senior machinery expert and of course part of the IEC 61400 draft group. We have Dr. Wolfgang Moser here from Innogy in Germany, who is a specialist in load calculations, so looking mainly on the model part of lifetime extension. Boelsmand Hansen from Vestas, also a specialist in load and enclosure, load and Fatrdla and load calculations from an OM. So he will give us the insights from a turbine manufacturer. We have Crowden from RWE or E.ON. Just recently, I don't know which is the right, but I would assume RWE is the right name for the company right now. He will give us insights in aging wind farms and inspections per se. Mark Spring, who is the convener of the IEC 61400-28, so he's leading the whole draft, and he will give us the insights from Lloyds Register. And my name is Karl Fatrdla. I'm an independent consultant with background in wind measurements, site condition measurements, which is also a quite important input factor to lifetime extension load calculations. So in that aspect, let me start and let me drop the first questions. What is the practical motivation, the drivers for doing lifetime extension? And Tommy, would you give us a little bit of insight what RWE is driving to look into extending the lifetime of really aging wind farms at the end of their lifetime?
Good morning, everybody. Yes, you were right, Karl. It is RWE. We've literally just moved across a month ago from E.ON. The drivers that we've had up to now have basically centered around the economics. Some of the older sites that we operate, we are still getting the renewable obligation certificate subsidies for, and we can still claim those through until 2027. So for us, if we're able to extend the life of a site up until 2027, most of the time that, from an economic perspective, is the way to go. We've looked at repowering some of those sites, and in instances so far where we've had, it's the life extension process which appears to be more economically favourable. This may be through problems that we've had with limitations placed on the sites or limitations placed on other aspects of the operations of the site, but mainly the drivers in the UK at least are to extend that period of getting that subsidy, because the new sites generally don't get it if they've been built up to 2017.
Thanks, Tommy. That was really valuable insight on what are the drivers and motivation in mainly the UK. Maybe Wolfgang, you can give us a little bit of insight why Innogy is approaching lifetime extension or is trying to go into lifetime extension. Maybe a little bit the insight from Germany.
Yeah. Good morning, everybody. I think the drivers are in all markets probably similar. In Germany, where Innogy is running a lot of assets, in particular, we have a political situation that makes the construction of new wind farms and the permitting process rather difficult. So where maybe a couple of years ago, repowering and construction of new wind farms was in the focus of many project developers and operators. This has now shifted, and lifetime extension has certainly become a very handy way of earning money with wind power without undergoing this permitting process and the auctions. So I think this has quite naturally from the constraints in the markets become a very interesting option for everybody, and therefore I think it's very good that there are also some initiatives to come up with standards and regulations that help us operators to decide which direction to take and how.
Thanks, Wolfgang. Also very valuable insights from why Germany is going more and more into lifetime extension. Rémi, how does it look like in your area, the French-spoken area? But we all know that Engie is a much broader company, really dealing worldwide with wind farms. So why is Engie interested in lifetime extension, and in your case, especially in through life management? But we'll come to that later on anyhow.
Hello, everybody. For sure, everything that was said before is quite valid internationally. But I would like to add also that safety is a major point. Safety, because we did face a few dramatic failures on turbine, blade loss or fires that were analyzed, and this is raising some uncertainty on the long run. So despite the fact that the turbine didn't reach the theoretical 20-year lifetime, we may have questions about what is the meaning of lifetime. And then we started to work on it. The second point, specific to the French market, was that most of the wind farms that were developed from the early 2000 are now reaching the end of the feed-in tariff. So those wind farms will enter the market, the electricity market, one way or another, either through PPAs or market prices. And this may not fit with the genuine business plan. So we have to think about ways to improve the profitability of the wind farm. Most of the wind farms are not facing big issues, and now being at year 15, we may afford to think going over the 20-year life. We don't have a mandatory system such as Germany to extend the production permit, but the operation permit. But still, the safety issue is really pregnant in the group, and we have for sure a big concern about that. So all those questions together brought to build a work group inside the company, and we are working on it for 2 years already.
Thanks, Rémi. Really additional value information here. Given all what you said, it would be quite interesting to see what is the real market for lifetime extension based on all these activities in with the large operators and owners. So I recently heard in a conference that the figures about the market are changing, where it has been in Europe about 10% of the existing fleet that shall be ready for lifetime extension and not going into repowering or dismantling. That figure should have risen up to 30%. Mark, what is the view on Lloyds Register on that market? What could you report from that?
Thank you, Karl. Yes, I just want to say just a couple of things. I'm working for Lloyds Register, and as an organisation, we can offer both verification services to underline and review the evidence provided for extended operation, both in terms of loads and also safety. And obviously for our clients, that may involve the commercial elements of that, but they would be making a judgment on that. And on the other side, so the second area that Lloyds is involved with is consultancy, where we might be undertaking some of those investigations ourselves. I don't want it to be a confusion to the audience that those two things are actually distinct. So obviously we don't do both in the same all parts of the organisation. But then I think your question about the context for life extension has to be answered with the lens of climate change, which has not been mentioned so far, pressing on all of us in this industry, and getting the full life cycle out of any assets into which has been invested significant amounts of energy, water, and thereby carbon dioxide. And so if there are turbines which can be operated efficiently, and at the moment the best way of judging that is based on their revenue and the full envelope commercial costs, which Rémi mentioned, then they should be, it seems to me, in principle. But what we've noticed is that there are big variations from one country to another, and if we're talking about life extension, then we're talking about turbines which may have been designed 25 years ago, and things have changed a lot in that time. We just witnessed during that period the plummeting of energy costs for full life cycle assessments of the wind farm projects, going from probably about 200 euros per megawatt hour in the late 90s down to about 40 now for offshore wind farms, and less still for onshore wind farms. But so when Rémi mentioned post feed-in tariff negotiations for contracts, those might include power purchase agreements with individual consumers, but they may also involve pitching in, supplying electricity at the pool price of the market for electricity, which is a big risk to the producers. Those kind of commercial contexts are probably much more applicable to current very efficiently designed projects than they were 20 years ago to the projects which were conceived then. But having gotten through the process of operating these wind farms for 20 years, the owners and the asset managers have a lot of data, a lot of experience. They've probably ironed out some issues to do with software, to do with repeat failures, to do with the way that they have managed to control the availability through their maintenance strategies. And I hope that will come out during this morning's conversations. So I think the key thing is that there are differences from one country to another. In some countries, there is a feed-in tariff, which is about to end. Contracts for difference in other countries with a baseline strike price for electricity. There may be contracts which outlive the permits. So that's where the health and safety aspects come in. And if that's the case, then there needs to be a mechanism by which the permits can be extended to equalize with the contracts, but only for those units, those turbines, which can be operated in an efficient and commercial way.
Thanks, Mark, for that answer. If we talk about the market and all the aspects of lifetime extension, all the things are leading, of course, to the business case. And here I would like to refer a little bit about the importance of documentation of the measurements we do during the operations, and mainly also the uncertainties that are involved in applying load measurements and calculations. Wolfgang and Mats will certainly refer about that later on, but that uncertainties are tremendously important for lifetime extension business case calculations, because they can take in directly in order to do P90 calculations on the extended life, which might be quite interesting and important for banks, lenders, insurances, because that could give them the basis to finance the extension of life of existing wind assets in the future as well. And if we're talking about 30% potential in Europe, I think that's quite a big market. And the clearer the business case calculation, the more standardized the business case calculation becomes, the better it is. Also, I have to say, business case economic context is not part of a technical specification, of course, so that won't be something that is comprised in the IEC 61400-28, but it will be driven by the outcome of the standard, because there the uncertainties play an important role. From the business case, let us come to the next, let's say, important question. What are then the important factors to be considered when we talk about through life management and lifetime extension? Mats, could you give us a little bit the insight from a turbine manufacturer? What are the important factors? Where's your focus?
Yes, hi everyone, and thank you for being here. At least Vestas, as being, you could say, a turbine OEM, I think a bit there is, you could say, a change in the philosophy, you could say, taking place related to lifetime extension, or has been taking place for the last years, where we are going away from more, you could say, semi-deterministic way for designing our structures in. You could say quantify loads, quantify stresses, and then in the end, it is based on a rather stochastic load input, here by wind, and then we add some safety factors on top, and then we are, you could say, verifying our designs according to that. And that needs to be taken more, you could say, in a data-driven way and a more probabilistic way, where we are taking in, you could say, how you could say learnings from the fleet, and you could say improving our inspection strategies and different other techniques, monitoring the component where it makes sense, etc. That is at least what we are focusing a lot on in the service solution department where I work in Vestas.
Thanks, Mats. That's really good insight. From the inspection point of view, Tommy, what are the important factors what are the important factors for RWE? Tommy, could you please unmute?
I double pressed. Yeah, so for historically, what we've done is yeah, there are a number of factors for putting a business case together. First is the sort of package of work that you need to do to fill out any gaps that you have in your information. So assessing loadings, inspecting welds, and other areas of the turbine. So there's sort of a knowledge gaining process, and that has a cost. And then there'll be the cost of any remedial works or upgrades or ongoing inspection requirements that would then have to be factored into the business case as an O&M cost going forward. So from a technical point of view, they're the areas that we would be looking at. And we've taken a more of a risk assessment type approach, which is common in the UK, which is to understand integrity risk and safety and then have a mitigation strategy around those risks. But one of the things I would pick up on for a business case are the sort of non-technical elements. So things like your land agreement with your landowner and trying to make sure that you can come up with an arrangement that makes economic sense there. Some land agreements may not have an end date on, some maybe you may not need to do anything there, but other sites we've had experience of where the sort of turbine life and the land lease agreement end at the same time, and that's put us in a challenging position when we go to negotiate. And also any requirements that may come out of extending planning permission. We've had pieces of work come out of the woodwork from planning, such as repainting turbines or cleaning turbines, and these, you will have done all of your technical assessments and ongoing O&M strategies, but these are other costs that may not necessarily be the headline figures, because people tend to focus on the condition of the turbine. So it's a whole package of technical and commercial elements that need to be considered for a business case there.
Thanks, Tommy. If we're looking on the operations, maintenance, repair side, Rémi, what are the important factors for you?
So I would like to come back first to the experience before to explain you what is important to me. We were relying for the last 10 years on mainly, at least in France, on full scope contract with the OEM, which was safe in the context with the feed-in tariff, because the costs were fixed and the revenue were fixed. That was fitting perfectly. Now the feed-in tariff is reaching the end. We have to think a different way, because despite the service was quite good, the knowledge was not building up internally at the operator to make us able to take proper decision. By this time, we had also many wind farms without those full scope contracts with the OEM, and that's where we learned a lot. I will make the connection with what I said before about the lifetime. Lifetime, generally speaking, doesn't mean much, because you may refer to the turbine lifetime, and in between, what is important on the financial point of view is what will happen before this end of lifetime, which is purely theoretical. Lifetime was aiming first to guarantee the safety of the turbine, meaning that only the structural parts were considered to be able to last 20 years without failures. And then all the major components may have failures in between, and that is creating high OPEX cost. So during this time, we realized that reaching the end of the contract and starting to think about what will we do next may be a bit tricky because the risk and the uncertainty will be very high without knowing the history and the trends that are ongoing for any specific major component, which will make most of the OPEX cost. Besides this, there is also this safety issue that needs to make sure that the theoretical life can be extended. And that's the point when we have to rely on history, data collection, but also repair analysis, root cause analysis that will help us either to improve the product together with the OEM and then extend the life, because the new component may last longer than the genuine one, and also to build the strategy to make sure that nothing will impact the outside of the wind farm, meaning that the safety will be ensured. And that's when we had to define what are the critical components that may not be structural, but that for which the failure can impact the outside environment and the neighboring. So this is the major point to me. And we started to build a monitoring strategy, because most of the turbines today are built to be safe, but based on thresholds. Those thresholds will guarantee the turbine to stop in case there is something wrong. When considering the lifetime extension, it may not be enough, because that's when the job starts. When the turbine stops, it's already too late. The failure occurred. And if we consider the safety of the turbine, if a failure may occur suddenly, then we could be in trouble. So we have to rely on monitoring, which is more relying on trends than thresholds. That's the main strategy today that we try to build. And based on this, we will be able for the future to have a better view on lifetime extension at any moment in the life of the product in the operation.
Yeah, that's really an important insight, that the earlier you start to monitor and document the conditions under which you are operating the turbines, you at the spot more or less know in which direction lifetime extension might go for that wind farm, and if it might be even extended, or if you're even reaching the originally designed life of the turbines, because they are operated outside of design specification. Thanks, Rémi. When we talk about factors, Mats, the OEMs, what are the, let's say, the designers at Vestas, but also at other turbine manufacturers are doing in order to facilitate lifetime extension very early on, and what are the programs behind that?
Yes, at least in Vestas, we are offering, you could say, different products. You could say we are, of course, different. You could say offering a service related to if you could say a developer or a specific owner wants to lifetime extend their asset, but we also are over the last years focusing more on the digital, you could say, data-driven approach, where we're using data analytics to support and maybe find trends in our, you could say, CMS or in the turbine, you could say, signals, to try to see if any abnormalities can be found, so we can hopefully try to, you could say, convert some of potentially unscheduled service to scheduled service, and therefore also support our customers in lowering the OPEX. There's a lot taking place, at least in Vestas, on that, and also where we see a big market demand on this. So yeah, monitoring is key, and I think that was highlighted several, both from Tommy and Rémi. Inspection-wise, you could say we also looking into more, you could say, cost optimized, but also improving the inspection, trying to rule out this human error in a way, you could say, being less dependent on the, you could say, human judgment, which could be an uncertainty. Yeah, that is also what we are looking into a lot. Yeah,
Yeah. No, thanks.
That
thanks,
is
but yeah. That's really good insight, because it is important that lifetime extension is already an intrinsic part of the turbine design, I guess. What we can see here from all the discussions we had so far is that obviously the multiple approach needs to be taken for lifetime, because we have very old assets with poor documentation, with almost no documentation. We have wind farms that are well documented. Tommy, how is RWE dealing with this? I know that you're working with a couple of wind farms that are really old, where documentation is poor. How do you approach that one?
Basically, we have quite a few wind farms where the documentation is fairly poor, and the available information coming out through the SCADA system, if the SCADA system is operational, while it's communicating to our centre, has been challenging. We have basically had to focus more on the physical inspection side of the work there. So have some civil engineering, structural engineering specialists come and climb all over the machines and then take an inspection regime from that. So ideally, we'd have good data, and you would hope that more modern turbines that are coming into the life extension arena would have more available data on wind speeds and loadings on the turbine. But yeah, we've really struggled. So I think some of the areas that we don't have are the design information on the towers, any of the loading models that have been built upon the towers. So we're sort of having to retrospectively calculate loadings and stressed areas on the turbines, and then carry out inspections to see if any of the modelling work that's done corresponds well with that. And that's going back into the sort of conventional generation world where a lot of these approaches have come from. That's generally been the case, to try and build some models and then corroborate the outputs from those with physical inspections and modelling.
Yeah, thanks. Wolfgang, from the other perspective, when documentation is well, you have condition monitoring data available. Let's assume ideally for the whole lifetime, what can a model provide us with then, or what are the, let's say, what is the importance of the model, and what can it contribute to lifetime extension?
Yeah, first of all, let me say that also in assets that are quite old, usually there is data, but the quality may be poor on the one hand side, and on the other hand, it might be very hard to really access this data. So I think an important point is that the operator should invest considerable effort in a rigorous data management, such that even if the data is scarce, at least it's available. And we should not forget that with technological progress, even data that might seem quite poor now might be an important input to, for instance, algorithms based on artificial intelligence, and now I'm coming to your question actually, Karl, or might serve as an input to very advanced turbine modeling in terms of digital twins that take data and run kind of parallel to old assets in order to mimic the behavior and to deliver data that allows to predict the trends that Rémi was talking about, future trends, and to assess the current state of the turbine. So there are many ways of tackling also assets with old turbines. For instance, there are very sophisticated laser-based measurements with which you can learn quite a lot about your turbine. You can measure the aerodynamic profiles of the rotor. you can retrieve very interesting and necessary features of the controlling from SCADA data. And even without the support of the OEM, you should be able, with all the documentation that you have, to build quite a reasonable simulation model that can be used in lifetime extension. Of course, the more cooperation with the OEM is possible, the better your results will be and the less the uncertainty in your prediction will be. And the second point I think that should be mentioned is that apart from the pure error elastic modeling, of course, there are also data-driven methodologies to predict lifetime. For this, though, you need to make a reference measurement on one of your turbines to be able to correlate data like SCADA data to loads and therefore to be able to predict lifetimes. I think there is considerable research going on in the wind community on these topics, driven by the business cases and the market requirements that we have discussed previously. And I think we are on a good way to go forward. What I also want to mention is that there are a lot of measurement techniques either already available or under development that come at quite low cost. And of course, they are not comparable to a full equipment of the turbine with an ISC compliant load measurement, but at a low cost, they can give already very good insight on what is happening on your turbine. And even if the asset is maybe 18 or 17 years old already, it's not too late to deploy these devices in order to collect valuable data for potential lifetime extension.
Thanks, Wolfgang. That, of course, leads us immediately to the next question. What kind of information, or which information are we actually missing today, which would improve, let's say, the whole approach for lifetime extension? Still, Wolfgang, and then I would like to ask also Rémi about this.
You like me to start, Karl?
Yeah, no, please start. Go ahead. Sorry.
Okay. What you mean? What is missing currently? Yes, where we need more input? Yeah. Well, as I said, what could considerably improve the quality of any lifetime prediction, which actually is nothing else than a risk assessment of your turbine operating longer and continuing operating, would be more input and more support from the OEM. As I said, the very common approach, at least in the German market, is to do kind of reverse engineering or using a generic turbine model to kind of do some basic predictions and to be able to identify hotspots that you need to inspect more closely and more regularly. However, this remains quite fuzzy if there is not enough information on the turbine from the OEM. So as I said, there are a lot of technologies for measuring wind, turbulence, and loads, but it is very hard to get access to the original design data and design basis of the turbines under consideration. And this would be a very good thing for us operators to have. I know that there are issues with intellectual property, of course, but maybe since we're talking about assets that are now 15 to 20 years old, maybe there is a way to establish a better relationship or collaboration with the OEMs in that respect. That would be one of my wishes.
Thanks, Rémi. What are we missing? And I would like to add, before you answer, I would also like to add, I think also the monitoring of turbulence intensity and wind side condition monitoring might add an additional quality to the load calculations and reduce the uncertainties and therefore improve the business case per se. Rémi, but you also have a couple of ideas what is missing and what each turbine should comprise and deliver in terms of data and information.
Yes, I would support both of you, Wolfgang and Karl, because there is this kind of theoretical process based on the assumption that the turbine was designed in a way it was facing some local loads, and from the loads that were already acting on the turbine, there is a remaining useful life. In parallel, I would advise to add also the physical process of earth monitoring. There are very simple techniques on monitoring that can help a lot. 10, 15 years ago, vibration analysis were not so common and then quite expensive. Today, most of the turbines are installed with vibration monitoring as a standard. But for some components, such as pitch bearing, main bearings, we may also add some quite simple old-fashioned way, such as grease analysis, that can be used in parallel with all the modeling and the analysis that can be done to see if the real life is matching with the theory. The problem is that most of the models are quite efficient on the fatigue point of view, but there are some failure modes that are very difficult to model. So it is worth also to check on the health of the component with techniques that are well known in other industries, but not very much implemented in wind yet. So beside this, I remind that data analysis to detect trends on temperature and things like that can help a lot to remove deviations before they lead to failures.
Thanks, Rémi. Then based on all what we said, there are certainly some risks involved with lifetime extension. And Rémi, I know that you have been looking into that. So what can go wrong?
Ooh, that's a wide question.
Try to be concise because we're running out of time here. So I'm asking you to give us just a glance into this.
Yeah, if I'm pessimistic, everything can go wrong. So the risk assessment should be based on the worst scenarios, and then you can sort out which one became realistic after you are running the monitoring, because the monitoring will show you the trends that will lead to failure. So from this monitoring and the inspection we mentioned, it will be quite easy. I put easy between brackets because it needs some expertise. It would be quite easy to select the scenarios that can happen. But for that, you have to think about the scenario upfront, and then you will select the one that are the most probable. So this will reduce deeply the risk if you are prepared already.
Super, thanks. So, Mark, finally, how can a standard like the IEC 61400-28 and possible certification help with lifetime extension and through life monitoring in the industry?
Thank you, Karl. I think I would very much be very interested in hearing what the audience has to say about this, because I think ultimately we need to respond sensitively to what are the requirements and the challenges and the urgent gaps that the industry sees. But I believe there has been strong support for an international benchmark, which clearly lays down the minimum requirements for evidence to demonstrate extended operation, and also to go back right to the beginning when the wind farm was first conceived, because for new wind farms we now know what we ought to be collecting, what information we should be storing available to help us to ensure that these assets are operated for as long as they are safe and productive to be run. And that some of that information goes right the way back to site assessment. It goes back to the original design from the manufacturer of the turbine, and it goes back to issues experienced during construction and throughout the life. And we've talked a little bit about how you use data to assess remaining life. And often we restrict ourselves to looking at fatigue because many components are driven by the accumulation of damage throughout their life. And at some point they reach the end of the capacity to continue to operate based on the accumulation of damage. But we shouldn't forget that actually there is information in the data about extreme events, and that might not be necessarily easy to extract because some of the flags and some of the warnings may not be reliable. We may have learned to mistrust the data that the turbine are giving us, but we can make some intelligent guesses using a combination of expert input from technicians who really know the turbines like the backs of their hands, and the designers who knew what they were anticipating, and data scientists who can bring in tools for mining that huge amount of data that we have. So all of that said, I think there is a great opportunity here to bring together the best knowledge that has been accumulated throughout the last, I would say, even 30 years or longer. And I meet from time to time really knowledgeable people from the industry who retain that experience that is built up for them over that period of time. They may have designed blades, they may have designed control systems, they may then have modified and improved them over their professional lives. They may have been operating wind turbines designed by somebody else, and projects that were conceived and set up by colleagues or previous companies, but they have a lot of knowledge because they are technicians who are there on site, seeing the conditions that the site has now, which may be different conditions from how it had when it was being first designed. And all of those people and the data can be used to help to prolong the life of the assets. And I think the key is for any kind of benchmark to reflect what could be done with that information, but not to be prescriptive, to prevent creative solutions from coming in the future. So currently we have this project team, which is set up by the IEC, the International Electrotechnical Commission, which will be writing a technical specification. And this will be published at the end of this year and circulated early next year around the national committees who have their own industrial representatives. And we're hoping that over the course of the coming 6 months, there will be an opportunity to improve the text of that document. And then probably in about a year or 18 months time, it will be updated to a second edition and become a standard. But this is a technical standard. And on top of that, we anticipate the IECRE, the International Electrotechnical Commission Renewable Energy Group, to develop assessments of conformity. So schemes by which the technical specification or the technical standard can be used and referenced by organizations and third parties who are being commissioned to review the case, the technical case for ensuring that the extended operating life is both safe and productive for the operators. So that's where we are now, and we have made very good progress. I'm grateful to all of the people on this panel, but also the wider team that you mentioned at the beginning, Karl, that we've made progress so fast, faster than I think many other project teams on the IEC, because this is urgent, but also we have, I think, the right team of specialists.
Yeah.
But there is also the opportunity for others who probably are dialed into this call to help direct the objective and the end goal of that text.
Thanks, Mark. Thanks to everybody in the panel, first of all, and we got questions, Lindsay.
Yeah, we've had quite a few questions in. Conscious that we're a little bit low on time, so what I'll do is pose Perhaps 2 or 3 of those questions to you now, and then anything else that we don't cover, we'll look to potentially pose to our speakers once the webinar has wrapped up. So the first question that I wanted to ask was, what is the view of insurance companies on lifetime extension?
Mark, I think that you're perfectly suited to answer that.
Thank you, Karl. Ultimately, if a project needs to be insured, then the risks need to be quantified, and I think that's where all of our panelists have a contribution to make. So Rémi is very knowledgeable about rotating equipment and bearings and lubrication systems and tribology. Wolfgang has a special knowledge on probabilistic analysis of uncertainty and estimating loads. Mads has a great experience from the design perspective for the turbines, but also for supporting their products throughout their life. And Tommy has a lot of experience with all aspects of the wind farm operation, but from design through to an innate knowledge of machines which have been operating many cases for 20 years or more. And those risks, having been defined, will all contribute to an estimate of the remaining healthy life, the implication of consequences for the commercial context, how much revenue will be generated after the design life, and the safety of personnel who have to go to the turbines from time to time, any kind of implications for other equipment in the space which may not have been there when the wind farm was first built. So other wind farms, forests, buildings, roads, and other areas around the wind farm which may be affected if any failures occur. And I think the insurance companies, if they're going to underwrite the continuing operation, need to know, firstly, there is going to be a revenue stream which makes sense for the project, but also that there are no liabilities which the project is responsible for, which may have cost implications or safety implications or regulatory compliance implications. And I would welcome any potential answers that may come from people with direct experience of insuring wind farms, and also of wind farm owners who may be listening, who have either chosen to self-insure, so to ignore the requirement for insurance, or have had to go through the process of contracting with an insurer and to identify what hoops they've had to jump in order to get that insurance premium to a level which doesn't make the project uneconomic.
Thanks. Lindsay, next one.
Sure. So the next question we have is, a lot of the focus has been on turbine components, which are obviously important, but in general can be replaced in worst case, so can build additional OPEX cost into modelling. What's the panel's view on foundations?
Very good question.
Well,
I think
it's an excellent question. In principle, but let me first of that answer, Mark. The foundations is something that we haven't included in the ISC, but at the end of the day, the same mechanisms can be applied. But I would rather like to forward that question to the specialists. Rémi, what is your view on that?
So I may not be the specialist for that. The only thing I can say is from the experience, we didn't see much failures compared to the numbers of turbine in operation with foundations. The cases I know were mainly due to design, and this is very a small amount according to my experience. So this question should maybe ask to the insurance companies, because they are the one with the larger statistics as far as I know.
Tommy,
monitoring of
sorry, Tommy, have you seen some issues with foundations? Yeah, sorry, Rémi, I didn't want to interrupt you. Tommy? Please unmute. No, we lost Tommy.
Maybe Tommy's having problems. Yeah, I was just going to say,
Yeah, we lost Tommy, but any other who would like to say something to foundations?
Yeah, maybe I can say something. Wolfgang speaking here. Of course, a foundation should be basically assessed as any other critical component of the primary load path of the turbine. Actually, the draft of the -21 it is perfectly applicable for foundations as well. And as all other components, there needs to be a theoretical assessment of a possible continuous operation or remaining useful lifetime, together with a risk analysis and the risk-based inspection approach. So if in many occasions, the foundations or the design of the foundation is not really driven by fatigue loads. But if a theoretical assessment should come to the conclusion that might be a critical spot, then some inspection measure has to be, or monitoring measure has to be deployed in order to mitigate the risk of a catastrophic foundation failure. But in general, I think that the methodology can be applied to the foundations as well. Of course, a foundation is a component that you don't see, so you need to be more inventive and more and smarter when it comes to inspection or health monitoring.
Thanks, Wolfgang. Lindsay, have we time left for another question?
We've got about 3 minutes left, so we've got time for one more question very quickly. So the question is, with the push to reduce the cost of energy across the markets,
could you
repeat that question? Yeah.
Yes.
with the push to reduce the cost of energy across the markets, how will this impact on the ability to extend life in the future?
Well, I guess that is a question that we have addressed already, Mark. I guess you have said something about that.
Yes, I think you're right. The question is absolutely pertinent. The current market is encouraging zero subsidy bids for wind farms, and previously 20 years ago they weren't available and it wasn't commercially acceptable. The benefit of extending operation, if there are no major retrofits of components to be done in order to make it possible, is that it ought to be relatively capital unintensive to continue operating an existing wind farm, and so that the costs should be lower. But the costs will also be known and the risks should be known because the data are all there. And so there just needs to be an economic assessment done, just as for a new wind farm, to look at the extended period.
Thanks, Mark. Lindsay?
Great. I think we've run out of time, unfortunately. We've had so many questions in, so just a testament to what a brilliant panel it's been today. What we'll look to do is sort of pose some of these questions that have come in to our speakers post-event, and then sort of send out, hopefully, kind of a follow-up email with those sort of questions in writing. Yeah, it's been a really, really great session. I hope everyone has enjoyed sort of listening in today and has felt that they've sort of gained a lot of insight. Just a final quick one from me about the context of the webinar, obviously produced in conjunction with Wind Operations Europe. We're currently running a offer which is such that you will receive a post-event report with your executive pass purchase ending this Friday. So do look at our website, which is on the screen, if you're interested, and you're more than welcome to sort of email me or contact me directly if you have any questions at all. But yeah, thank you so much to all of our panelists and also to our audience for listening in today. And yeah, thank you very much.
Thanks, Lindsay. Thanks to all of you guys. I also enjoyed that discussion round a lot. I hope the audience did it as well. Thanks.
Bye now.
Thanks. Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye, everybody.
Have a nice afternoon.
Thank
Goodbye.
you. See you. Bye.